Hello students, in today's lecture video we are going to start our chapter 9, which is about acids and bases. We will learn how to name, how to recognize the compounds as acids and base. Okay, so a person who has not taken chemistry as a class course may not know about cations and anions and other terms related with them. But many of us, either though we do not know much about chemistry, we have heard about acids and bases. Okay, so the term acids and bases came from the ancient time. Any compound that was more sour in property, in testing, they were known as acids. So acids came from the Latin word acidus, which means sour. Okay, so in today's class we are going to learn their properties. Maybe later on we will learn about the reactions, all about that. Okay, so let's introduce. The word acid was actually coined by, definition was coined by scientist Arrhenius. So we call Arrhenius acids and bases. According to him, an acid contains a hydrogen atom and dissolves in water to form a hydrogen ion. So a compound that has hydrogen in the formula, right? And when it dissolves in water, it is capable of giving away the hydrogen ion. Hydrogen ion means H plus. Okay, hydrogen ion can be given away just like how in the example HCl gas when dissolved in water gives us H plus and Cl minus ions. We call it acid. HCl is called acid. Similarly, according to Arrhenius, a base contains hydroxide in them. Okay, OH is the hydroxide. OH that has a minus charge is a polyatomic anion. So whenever a base dissolves in water, it will break down into cations and then the anions will be OH minus. Okay, so we call them bases. For example, sodium hydroxide, potassium hydroxide, lithium hydroxide, etc. Okay, so let us look on. So Arrhenius' definition correctly predicted the behavior of many acids and bases. Okay, we could classify compounds into acids and base on the basis of that definition. However, that definition is limited and sometimes inaccurate. Okay, why inaccurate? For example, H plus, which we say is given away by the acid, it does not exist in water. When we use some instrument to check what is the property, what is the chemical form of the things, species, then actually that H plus reacts with water molecule and it forms hydronium ion. And when H plus get attached to H2O, it becomes H3O plus. So actually, literally it is hydronium ion that is present in the aqueous solution, not H plus by itself. Okay, but according to the definition, it sounds as if the H plus exists itself, right? Which is wrong. So Arrhenius' definition was a little bit limited on those terms. Okay, so hydrogen ion does not really exist in the solution. It is actually the hydronium ion H3O plus that exists in aqueous solution. Okay, now we know that. So later on, we had other definition come up to explain or classify the compounds into acids and bases. One of them is the popular one, accepted one is Bronsted-Lowry definition. Okay, according to Bronsted-Lowry definition, acid is a proton donor. Okay, now that H plus that we were talking about hydrogen ion in Arrhenius definition is known as a proton here. Okay, because you know that hydrogen atom has one electron and one proton, right? One proton in the nucleus and one electron on the outer shell. When the electron is given away, right, hydrogen atom has only proton in the nucleus, right? Nothing else. So now we can call that H plus as a proton. So either you say H plus means it lost one electron and become H plus, or you say proton, they are same thing. Okay, but it was Lowry Bronsted who brought up the word proton for the H plus. So those acids who can donate the H plus, who can donate the proton, are known as acid. And those compound who can accept that H plus, or say those are the proton acceptor, we call them base. Okay, so let's see here one example. We have HCl, right? HCl gas in water, in liquid water. So when HCl gas dissolves in liquid water, what happens is that H plus of the HCl is given away. So proton here, H plus, is donated, and that H plus is accepted by liquid water. Now that liquid water, after H plus you add there, the formula becomes now H3O, and it has plus charge, right? So water accept the H plus, so we call water here base. Okay, and since HCl gives away the H plus, we call this guy acid. Okay, so it forms hydronium ion, and whatever left after giving away H plus is Cl minus. That is also a side product here. Okay, so according to this definition, proton acceptor or proton donor, HCl is the proton donor, so we call it acid, and Cl minus is and water is the proton acceptor, so we call it base. Okay, so yeah, same thing is explained here. When you add HCl gas into the water, now that HCl will break down into H plus and Cl minus. H plus will go and attach to water molecule and it becomes hydronium ion, right? Now, we just mentioned that to become acid, either it is RNS or Lowry Bronsted, they must contain a hydrogen atom. Because if they have hydrogen atom, they can make proton, right? And then proton will be, or hydrogen ion, that can be given away, right? So in the formula, you will always see hydrogen if it is an acid. Okay, for example, we have here hydrochloric acid, HCl, hydrobromic acid, HBr, nitric acid, HNO3, sulfuric acid, H2SO4, and acetic acid, CH3COOH. This H that is attached with the oxygen on one end, this is the acidic hydrogen atom. And all these hydrogen that are acidic in nature will be given away. Okay, so and now we will see how do I know all these names just by looking on the formula, right? How to write the name if we see the formula. We will learn that in a while. So let's classify the acids, okay, Bronsted-Lowry acid, or you can say RNS acid, into different classes depending on how many hydrogen can be given away. Okay, so we call acid monoprotic if it contains one acidic hydrogen or one hydrogen that can be given away, right? So HCl, HBr, HI, those are the example for monoprotic, because all they have, okay, because all they have is one hydrogen. Now diprotic, those acids, right, those acids who contain, so let me show that, my pen is acting weird. Those acids that have two hydrogen, right? Two acidic proton that can be given away. For example, sulfuric acid here, we call it diprotic. Now you get it. If it has 3 hydrogen acidic proton, it called triprotic. Okay, so acid can be a neutral. Sorry, where did I lose it? I lose something. Acid can be neutral like HCl. It can have positive charge or it can have negative charge. Okay. Now let's try to give the name, how to write the name for these acids. The name of acids are, first we will talk about acids, then we will learn about bases. The name of acids are derived from the anion that formed when they dissolve in water. Okay, it means that anions whose names end in "ide" add prefix hydro and change the "ide" suffix into "ic" acid. Okay, so if you have some compound that can form chloride ion, then since we have chloride as an anion, we make it chloric acid, and then we have to add hydro word in front of it. So we have, for HCl, it is hydrochloric acid. Okay, if I have something like HBr, then this HBr will have, you can understand this one has H plus and bromide ion, right? The anion ends up with bromide, ide suffix, so I make it bromic, and then I have here hydrogen, so I write it hydrobromic acid. Okay, so similarly HF will be hydrofluoric acid, HI will be hydroiodic acid, and HCN would be hydrocyanic acid. So whenever the anion that can be formed has ide, you make it ic acid and then add hydro in front of them. Okay, do not forget to add hydro in front of them. Now, if we have the anions that are polyatomic, okay, it means their name will end up with the suffix ate, right? Chlorate, sulfate, bromate, something like that, right? If anything ends up with 8, then we just need to change that 8 into ic acid. We do not need to add hydro in front of them. Okay, let us see this with an example. If I have sulfate ion, why is this giving me the cursor all the time? I'm not trying to use this as a cursor. Okay, anyway, so I have here sulfate, right? Let me go back. Maybe this is not working. Okay, I have here sulfate, so I have to make the acid name sulfuric acid. Okay, so the formula H2SO4, okay, has the ion sulfate, so I write the name sulfuric acid. I do not write hydrosulfuric acid. Okay, this is because the name of the anion ends as 8, not as ide. If the, let me show you, H2S, my pen, H2S. If I have something like H2S, S is sulfide, so this one becomes hydrosulfuric acid. Okay, H2S. H2SO4 has sulfate as an anion, so now it becomes sulfuric acid. Okay, I do not add hydro in front of that. Please remember that, because sometimes a student get confused with that. Whenever I have polyatomic anion that ends with 8, I do not write hydro. That's all. Next, if we have polyatomic anion whose names end in ite, ite, then change that ite into us acid. So if we have something like sulfide anion, okay, the formula gives away, or the formula makes the sulfide ion, because when you break this one, it becomes H plus, 2 of the H plus and SO3, 2 minus, right? Sulfide, then we call it sulfuric, sorry, now the acid, the corresponding acid is sulfurous acid. Okay, 8 becomes ic, ite becomes os. Let's do some learning check. Let's check if we have understood that or not. What is the name of this acid? HBr. Right? First of all, HBr means it has anion Br minus. Right? If it has Br minus, then ide, bromide, right? Ide becomes ic acid. And then also I have to add hydro in front of that hydro prefix. So the answer is hydrobromic acid. Right? C is the answer. Let's try another. H2CO3. Right? If I have H2CO3, then I have the anion. H2CO3 means it's H and CO3, 2 minus, and I have 2H plus given away, right? When this break down in water, I have 2H plus, okay? And CO3, 2 minus. This is carbonate ion. If it is carbonate ion, means I have now carbonic acid. I do not add hydro in front of that. So carbonic acid is the correct answer for this acid. Okay. So here, this is the slide that you can understand, you can look, you can check yourself, you can do the learning check. All the anions, their name are given here, and the corresponding acid with those anions is given here. Okay, you can cross check your understanding, like chloride, bromide, they become hydrochloric, hydrobromic acid. If you have nitrate, sulfate, they become nitric, sulfuric acid. If you have something like sulfite, then we have sulfurous acid. If the anion is perchlorate, then the acid becomes perchloric acid, right? Similarly, you can check. First check the anion, know the name of the anion, and then go for the corresponding name of the acid. Okay. If we have acetate ion, then the corresponding acid is acetic acid. Okay. Now let's look on the bases. As we know, the Bronsted-Lowry base means they are the proton acceptor. So since they have to accept the proton, the H plus is something that is poor in electron. Okay, H plus, the positive charge means the electron has been already given away. This guy is poor in electron. So the base must have some lone pair of electron, because the base must be rich in electron, right? So that it can be used to form the bond with the proton. So a base must contain a lone pair of electrons that can be used to form a new bond to the proton. Here we have an example, NH3. This is the Lewis structure of ammonia. NH3, where nitrogen has the two lone pair, right? A pair of lone pair, two lone electrons. So this pair can be used to make the bond with H plus that comes from the water. Okay, so then they make NH4 plus ion, and when water gives away the H plus, the leftover is OH minus, right? The OH minus is left. Then that OH minus is here surrounded by other water molecules. So we have aqueous OH minus for it. Okay. So the lone pair make these neutral compound bases, like some others are like water can act as a base, ammonia can act as a base, because they have lone pair on these electronegative atoms, right? Water has lone pair on its oxygen. Ammonia has lone pair on its nitrogen, and these lone pairs can be used to make the bond with the H plus that is coming from the acid. Okay, that's why the acids and bases go for the good combination, neutralization, because acids gives away the H plus, which poor in electron. Bases are rich in electron. Now the transaction takes place there. Now the relationship forms there, right? So for the naming part of base, since the base have OH in them in the formula, their name ends up with hydroxide. So NaOH is, Na is the sodium, OH is hydroxide, so we call it sodium hydroxide. KOH is potassium hydroxide. MgOH whole 2 is magnesium hydroxide, and calcium hydroxide on the last, right? So generally the bases, they do have OH in their formula, or they do have lone pair on the neutral compound, and some common examples are ammonia and water we just saw. Now let's do the learning check over here, whether we have understood how to name the acids and base properly or not. Let's do a quick one here. So the first one is HNO2. First of all, whether it is acid or base. It has a hydrogen in the formula, no OH, right? So it is the acid. And HNO2 means you can break that into proton, right? And you go for NO2 minus 1 charge. If you remember the polyatomic anion, I told you to memorize, maybe in chapter 2, or we just saw a couple of slides before on a slide, right? The anion, this is a nitrite ion. Okay, so NO2 minus, this is nitrite ion. So whenever we have ITE, it becomes nitrous, right? Os. So we have here nitrous acid, right? So we have here nitrous acid. This is the correct answer for the first one. Okay. If I had nitric acid, the formula would be HNO3, right? So if I have HNO3, then this is nitric acid. Now, CaOH whole 2, we have here OH, so it is a hydroxide, so it is calcium hydroxide, right? So I have here calcium hydroxide. H2SO4, we have sulfate ion, so it is sulfuric acid, polyatomic anion, so no need to add hydro prefix there. I have here HiO3. This is H is the hydrogen, IO3 will make iodate ion, right? ATE as the prefix suffix there, so it becomes ic acid. No need to add hydro in front of that because it is polyatomic, so the answer is iodic acid. NaOH is an easy one, it's sodium hydroxide. Okay, so I think please check this slide that has all the different anions, polyatomic and monoatomic anions and corresponding acids on them. Read that, understand that, then it will be a lot easier to write the formula from the name or getting the name when formula is given. Okay, so in today's lecture video, we learn how a compound can be classified into acid and bases. We learn how to name these acids and base. Okay, so please practice. Thank you. We will continue the chapter in next lecture video.